Hello everyone. Today we will see a problem on modeling of control system. Previously we have seen problem on modeling of control system with respect to the translational systems. This is a rotational system where you are having angular displacement, you have inertia, you have torque and your spring and the dashpot, and here you will be dealing with the angular acceleration, angular velocity and angular displacement. Okay, so the mass replaced by that is replaced by j, which is called as the inertia, and x which was displacement in the translational motion, translational system, it is replaced by theta, that is the angular displacement, and your spring and the dashpot both remain same. That is, spring is represented by k itself in both the systems, and this friction here in this problem it is represented by F, but usually it will be B itself, that is capital B. Now we have to draw the equivalent mechanical system for this given rotational system. So here you have two displacements, that is theta 1 and theta. Now you have due to torque T, J1 it is under the displacement theta 1, and due to spring K it changes to what? Theta. Okay, and the inertia J2 and the friction F, these are under the displacement theta. So here you are having two displacements, that is angular displacements, and in the equivalent mechanical system you will have two nodes. Now we draw the equivalent mechanical system. So here we will take first two nodes, one will be theta 1 and another will be theta. Okay, so under the influence of theta 1 you will be having torque T, you will be having J1, and K is in between J1 and J2. So here you are having first your torque T under the influence of theta 1, then you get J1. Okay, so J1 again same thing here, as mass is, it cannot be placed in between the two displacements. Here also J, that is inertia, it cannot be placed under the influence of, that is in between the influence of two nodes. It can be under the influence of only one node. So here this is your 1, and K in between theta and theta, therefore here you will get K. Fine, and J2 again same thing, it will be under the influence of theta, it cannot be under the influence or between the influence of nodes. Then you have dashpot, that F, here the problem is represented F, that is friction. We will represent the friction by dashpot. Now we need to write the equilibrium equations for these. So here we have as we have two nodes, we will be having two equilibrium equations. Okay, so first we will write for theta 1, that is at theta 1. Okay, at first node. So at first node, here you are applying the force, that is here it is represented by the torque. Therefore at the LHS side you will get T is equal to here you have J1, which is similar to the mass in the translational systems. So along with J1 you will get the acceleration. Here you will be getting the angular acceleration, the double differentiation of your angular displacement. Okay, then next you have the spring, which is in between these two nodes. So as we are currently writing the equilibrium equation for theta 1, we should write it as K into theta 1 minus theta. If we are at the second node, we will write it as theta minus theta, because writing the equation theta 1, it will be K into theta 1 minus theta. Next for theta, next equation will be for theta. So here you will get as there is no torque here, the LHS side will be 0. Okay, and again you have to write J2 into d square theta by dt square plus have what represented by f. Okay, along with dash what you will get? You will get angular velocity that is represented by d theta by dt, then plus k into, now you are writing the equation for the second node, that is theta. You will get theta first minus theta 1. Fine. Now we have to write the Laplace transform of both these equations. So we will write the Laplace for first equation. So here you will get it as theta of s. Okay, this t theta t of s, that is equal to j remains as it is. Then you have d square theta 1 by dt square. It will be written as s square theta 1 of s. Okay, then plus k will be as it is, theta 1 will be written as theta 1 of s minus theta of s. We will take this as equation 1. Next we have to do the Laplace for the equation for the theta. So this 0 remains as it is, j2 remains as it is, and d square theta by dt square will become s square theta of s plus f into d theta by dt. It will be written as f s theta of s plus a into theta of s minus theta 1 of s. This will be your equation 2. Now we have to write the value for theta 1 of s from equation 2. Okay, from equation 2 we can write the value of theta 1 as, so here we will transpose this theta 1 on the LHS side. So what you will get here is you will get theta 1 of s is equal to, okay, so here this remains same, j2 s square theta of s will remain here only, f s theta of s will be same, this term will be k into theta of s. Now from this term and this term you can take theta of s as common, so here it remains j2 s square. Then from this term we will get it as f into s, and here we will get it as k. So this minus theta 1 of s into k we have transposed on the s side. So theta 1 of s will be this whole divided by k. Okay, now we have to use this value of theta 1 in our equation 1. So what we'll do, we'll use the equation in equation. Okay, what we'll get, what equation 1? Equation 1 is t of s. Okay, we'll write t of s that is equal to, next what you have j1 s square theta 1 of s plus k into theta 1 of s. Okay, and next I will split this. Okay, I'll rewrite this equation. So I will write this equation 1 as write it as, from 2 I can take theta 1 of s common. So here is 2. So I will write it as, just a minute. Sorry, you have to use the equation 1. So here we will write it as theta 1 of s into what is j1 s square, okay, plus k minus k into theta of s. Okay, we rewritten this equation, and in this equation we'll substitute value for theta 1 of s here. What is theta 1 of s? It is theta of s into j s square plus s plus k. So for that we have to place this equation, this whole divided by k into j1 s square plus k, okay, minus k theta of s will be as it is. Fine. Now what we want? We want to obtain the transfer function. Okay, what is there in the problem? In the problem we want to obtain theta of s by of s. So from this equation we have of s as well as of s. Now we have to write the equation such that we get the transfer function as theta of s by t of s. So here we can write it as, so here take t of s is equal to, this will be theta of s into j2 s square plus fs plus k into j1 s square plus k minus, here if you take the LCM it will be k. So here it is 1 into k will be, this will be k square theta of s. Okay, so this will be whole divided by k. Now what we have to write? We have to get the value for theta of s by t of s. So here theta of s by t of s, this is equal to, we will put this theta t of s here and we'll reciprocate this. What you will get? You will get k divided by, okay, j2 s square plus fs plus k into j s square plus k minus k square. So this is our theta of s divided by t of s, which is our required transfer function. Fine. This is our answer. I have understood the problem. Thank you.